Have you ever wondered what controls the flow of electricity inside your electronic devices? The secret lies in a tiny component called a resistor. Today, let's learn everything about resistors in simple terms. First of all, what is a resistor? So, a resistor is a passive electronic component that opposes or resists the flow of electric current. Think of it like a narrow pipe in a water system. It limits how much water or current can flow through. Then we will see the symbol and unit. So here we can see this is the symbol for resistor. The symbol for resistor is zigzag line. Then the unit of resistance is ohm. So here we can write the unit of resistance is ohm. Named after George Simon Ohm. He was the German physicist. Then we will see Ohm's law. So this is the Ohm's law. According to Ohm's law, the behavior of a resistor is governed by Ohm's law. V is equal to I into R, where this V is the voltage across a resistor and its unit is volts, and I is the current through the resistor and its unit is ampere, and R is the resistance and its unit is ohms. This means if you increase resistance, current will decrease. Then let's say this is a circuit and this is a voltage source of 10 volt and this is a resistance of 5 ohm. So we can find the current by using Ohm's law like this. I is equal to voltage upon resistance. So it is equal to 10 by 5 and it is equal to 2 ampere. So as we increase the value of resistance, the current will decrease. Now why do we use resistors? So resistors are used in circuits for many purposes, like to limit the current. Suppose we have to protect the LED. So to protect the LED, we need to limit the current. Then to divide voltage between components. Suppose if we want to divide the voltages between components, then we use resistors. Then to pull up or pull down digital inputs. That time also we use resistors. Then to set time delays in combination with capacitors. That time also we use resistors. Now let's see some real life examples. In a fan's speed controller, resistors reduce voltage to control speed. If we increase the value of resistance, then the value of or the speed of fan will decrease. Then similarly, in LED circuits, a resistor ensures the LED doesn't burn out. So to protect the LED or to limit the current through LED, we use resistor. Then in TV remotes, resistors help control signals. So resistors are also used in TV remotes. Now what are the types of resistor? There are different or various types of resistors like fixed resistor. So fixed resistor value doesn't change and they are the most common. So most commonly we use fixed resistors. Then next is variable resistor. So variable resistors are also called as potentiometers. So here we can adjust the resistance value. Then next is thermistors. So thermistors are the resistance changes with temperature. Then next is LDR. So LDR stands for light dependent resistor. So here the resistance changes with light. Now next is power rating. So here we will understand this with an example. So every resistor can only handle a certain amount of heat measured in watts. So here we can see this is the power rating. 1/2 watt is the power rating of this resistor. So commonly they are like these ratings are like 1/4, 1/2 or 1 watt, etc. So if the current is too high, the resistor may burn out. So if the current is more than this power rating, then this resistor will burn out. So how we can find the power? So here is an example. So power is equal to voltage into current, and there is one more formula to calculate the power. So power is equal to V square upon R, and there is one more formula to calculate power, which is power is equal to I square into R. So here the value of resistance and power is given. So if we take this R on this side, so we get the value of voltage. So here we will take this formula. Power is equal to voltage square upon resistance. So if we multiply both side by R, then it will be R into P, and this R will get cancelled. So what's remain is R into P is equal to V square. So if we take under root on both sides, then it will be under root of V square is equal to under root of R into P. So it will be V is equal to, now here the value of resistance is 100 and the value of power is 1/2 watt. So 100 into 1/2, it will be 50, and if we take the under root of 50, it will be 7.07 volt. So this is the maximum voltage that this resistor, or this is the maximum voltage we can apply to this resistor. Now, how to use resistors in circuit? So we can either connect the resistors in series like this. We can connect these in series. So this is the series connection. Let's say this is R1, this is R2, and this is R3 up to so on. Or either we can connect it in parallel like this. Let's say this is resistor R1 and this is resistor R2 and this is resistor R3 and up to so on. So when we want to increase the resistance, that time we add in series. So this is series and this is parallel. So when we want to add the resistance, that time we add in series, and when we want to reduce the resistance, that time we connect the resistors in parallel. Also, we can use a breadboard to test a resistor circuit easily. So now you know what a resistor is and how it works and why it's so important in electronics. Without resistors, our devices wouldn't function properly or even safely.